everyone. Going to get started now. So welcome to my talk. The title of my talk is Towards a Vendor-Neutral Kubernetes. And the main goal of my talk is trying to address some of the scaling issues we have as we try to support the ever-growing list of platforms and distributions that want to run and support Kubernetes. So before we dig into some of those topics, I want to talk a little bit about myself. I'm one of the co-chairs of SIG Cloud Provider, and I'm a software engineer at DigitalOcean. If you're watching the recording of this talk, or we don't get a chance to chat at KubeCon, you can reach me on Twitter at @SIGCam. So I usually start my talks with an agenda, outlining what things I want to talk about, but I'm going to actually start with what things I'm not going to talk about. So this talk is not about multi-cloud Kubernetes. I think what we're going to talk about is going to play an important role in the multi-cloud Kubernetes effort, but this talk is not going to be specifically about how to operate and run multi-cloud Kubernetes. Secondly, this talk is not a how-to on supporting new vendors or cloud providers in Kubernetes. I will be addressing how the Kubernetes community is supporting new cloud providers in the ecosystem, but I won't be covering the intricacies and the details of how to write the various plugins to support a new cloud provider in Kubernetes. Lastly, this talk is not about comparing vendors and distributions. I know many different distributions of Kubernetes that run on top of various vendors have kind of different sets of functionalities and features, and there's definitely trade-offs for all of them. But this talk specifically is not going to be trying to compare all those different things. And so if you came to this talk and you wanted this complete breakdown of all the different vendors, I'm not going to be talking about that. So this talk is more focused around how we're going to extend and customize Kubernetes so that it can run on any cloud, right? So public, private, hybrid, you name it, right? The goal here is to get to a point where Kubernetes is truly cloud agnostic. And it's hard to talk about this without talking about the concept of Kubernetes, the concept of cloud providers within the context of Kubernetes. Because really the term cloud provider is pretty broad and it can mean a lot of things. But in Kubernetes land, the term actually links to certain things in the ecosystem. So within the context of Kubernetes, when we talk about cloud providers, really we're talking about this abstraction that bridges together the various cloud resources that build up the cluster back to the actual Kubernetes resources themselves. And so if we look at it more concretely, the way we abstract this concept to work across any cloud is to have interfaces, right? And then these cloud providers then build implementations of these interfaces, and kind of the core of Kubernetes then just calls out to these interfaces to accomplish those things for that specific cloud provider. And what we have in place today are for things like nodes, right? Adding information like instance types, regions, zones, node states, those kind of things, and linking them back to things like node conditions or labels or annotations. Likewise for load balancers, when you create a service of type load balancer, we call out to the load balancer's interface and we kind of offload the logic to the cloud provider to figure out how do I create a cloud load balancer based on this service's specification. There's also routing and IP address management that's important to make virtual cloud networking on your clusters work properly. And then lastly, there's volumes, right? Associating persistent volumes to block storage services or object storage services on your cloud provider. So with these abstractions in place, we need to ask ourselves, is Kubernetes vendor neutral? Or in other words, is it cloud provider neutral? And that are we offering these features and these functionalities in a consistent way across any cloud provider that wants to support Kubernetes? And it's actually hard to reason about this without talking about entry and out-of-tree cloud providers. So the best way to kind of dive into those two concepts is to actually dig into some of the history behind why we even have this entry and out-of-tree concept. And so when we talk about entry cloud providers, we're talking about the way we implemented cloud providers from the get-go, right? So this was to assume that every component in this Kubernetes system, except for the scheduler, is going to be cloud provider aware. meaning that you can set some cloud provider flag on each component, and then it would then know how to query the various cloud APIs and the metadata services to achieve those cloud provider features we talked about earlier. And so the development workflow would be to work within the core Kubernetes tree, case.io/Kubernetes, which is why we call it an tree. That would essentially give us this native Kubernetes integration where we tightly couple the cloud providers into each component of Kubernetes. And so by nature, that also meant that if we make changes to the cloud provider, we have to actually ship together with the rest of Kubernetes in a release. And at a certain point, we realized this way of supporting cloud providers wasn't scalable. And Tim Hawken had originally suggested this idea of external cloud providers. And that kind of kicked off the work for us to start pushing all the necessary changes to sustainably support new cloud providers in our ecosystem. And so out of Tim's suggestion, we built this new architecture that supports the ability to plug in a cloud provider that is highly decoupled from the rest of Kubernetes. So in this new architecture, we want the core pieces of Kubernetes, the API server, the controller manager, the kubelet, to be completely cloud agnostic. And we want to give all the logic of the cloud provider specific things to this new component we added, which was the cloud controller manager. So from the development perspective, the hope is that we can develop, test, and release all the individual cloud providers in their own tree. And then that allows us to completely decouple all the cloud provider logic from Kubernetes. And so this was the angle that we had envisioned. But what we have today is that the various cloud providers that supported Kubernetes early on are still in this in-tree architecture, and then some of the more recent providers have had to adopt this out-of-tree architecture. So with that context in mind, if we ask ourselves again, is Kubernetes cloud provider neutral? I think the disappointing answer is that it still depends, because it really does, right? It's hard to draw a clear distinction because there are various advantages and disadvantages to going either way. So if you maintain an in-tree cloud provider, one advantage is visibility, right? When people want to run Kubernetes, they're going to check, what cloud providers are natively supported. They might read through the code base and look at what cloud providers are in that, that list of core providers. And this is naturally going to be a good thing, right? Because you're essentially raising awareness for your platform just by having your code live in a specific repo. But then advantage out of tree is that because your code doesn't live in case.io/Kubernetes, you can iterate on your features and bug fixes significantly faster. And from my experience maintaining the DigitalOcean cloud provider, we're finding that this is really beneficial for us because we can add those new features without having to wait 3 months for that next Kubernetes release. Or if it's urgent, I don't have to go through many approvals to get a patch release in for my cloud provider. Advantage in tree though is that you get to use all the tooling that we have upstream, right? This includes test coverage with end-to-end testing, all the linting and code checking. You also get this sophisticated CI bot that helps you manage all your PRs, issues, and whatnot, right? So that's an advantage. But then advantage out of tree is you not using those upstream tools, right? Maybe you don't want the extensive end-to-end testing for your cloud provider. Maybe all that amount of testing is really not necessary for a use case. Or maybe you don't trust the CI bot to manage your PRs and you'd rather just triage everything yourself. And so this is an advantage if you're out of tree. Advantage in tree is you're more likely to have contributors, right? If your cloud provider code lives in that Kubernetes core repo, and you're going to have more people seeing your code and trying to contribute, and you're going to have more exposure to the ecosystem. But then advantage out of tree is that you have flexibility and ownership, right? Maybe you want stricter ownership of your code base, or you have a specific cadence of releases you want to follow based on your company objectives. And so being out of tree gives you that full control. So as you can see, it's hard to really say if Kubernetes is vendor neutral today. But what we can say is that this way of integrating Kubernetes, this split we have, in-tree, out-of-tree, is inconsistent. And this inconsistency sometimes makes it harder for us to reason about certain architectural decisions, or it leads us to add features that may not address the concerns of all the cloud providers in the ecosystem. too often we find ourselves supporting use cases for one provider that may not be used by any other provider, right? And so having this consistency piles on technical debt over time. But I think what's really important is that there's strong community acknowledgement on this issue. I think we're all kind of seeing the same sort of problems regarding like how we've supported cloud providers previously. And I think one important thing to note is that, this split in entry-out tree is not intentional. Like I think it was just how it was organically built. At the start, it just made sense to put cloud providers next to everything else in Kubernetes. And so we started from there, and then as we grew the project, we had to figure out a new way. And so it was no one's intention to have the split, right? And with that, we're trying to converge towards one model, right? So we have a consistent story for how cloud providers can integrate with Kubernetes to support the platforms the best that they can. So where does that put us today, right? We know what the end goal is, but where are we now, and when are we actually going to get to this, this one converged model? And so today we have 8 cloud providers in tree. Again, these are the early adopters of the project that have kind of been grandfathered in. And the end goal here is to migrate any cloud provider's entry to their out-of-tree respective repos. And a common question I get asked is, why is this taking so long, right? This seems pretty important. We really want Kubernetes to be cloud agnostic. It's been like 2 years since we kind of had those initial discussions about this new architecture. And I think like when we first released like the out-of-tree idea, it was like version 1.7 or 1.8, right? So it's been quite some time since we've been working on this. And I think the reason why this effort is taking so much time is because we really need to be mindful of this transition for our users who are going to be running Kubernetes in production, right? Once code touches production, it becomes really hard to change it or remove it. I think the Linux kernel has many great examples of this, where once a system call is used in user space, it's very unlikely that we're going to see that being changed or removed. And likewise, as we see this like rapid adoption of Kubernetes, like we really need to be mindful of not breaking our users. And so we may not offer the same guarantees as user space Linux, but again, we really need to be thinking of this migration without breaking production for anybody. And if we look at kind of like what is the fallback mechanism, right? We need to plan for this transitional period where we can run both the core parts of Kubernetes and the cloud parts of Kubernetes in either architecture. So this is so that users within the same Kubernetes version can switch from one cluster configuration to another to make sure that when they try this new configuration and they find some critical bug or some behavior that doesn't work that they assume would work, they can easily roll back by just changing some flags. And so yeah, like with the rapid adoption of Kubernetes, like it's really important that if we're gonna introduce a change this big, we really need to have a solid rollback plan. And it gets even more complicated when we bring storage into the picture. While we're trying to move the cloud providers out, we're also moving these storage plugins, which require their own migration path. So in this case of migrating the Cloud Volume plugins to CSI, we need to temporarily add this translation, CSI translation layer library between the volume plugins in the kubelet and the CSI driver, so we can fall back if we find any critical bugs in the CSI drivers. And one of the biggest challenges with migration like this is you want to do this without blocking or breaking development for others. The last thing we want to do is to fork a code base and have to maintain like both the entry out of tree and trying to keep those changes in sync, right? So we're trying to shift more responsibilities of the system to these external plugins, but we still want to have everything under like one single source of truth. And one way we work around this in Kubernetes is to we have these like staging repositories, and what staging repositories lets us do is to work on top-level external repositories within the same Git tree. So this gives us a really smooth transition into splitting code within the main tree out to their own use. So there's really 2 key things that you can do once you stage a repository in Kubernetes. First is that you can actually vendor what's staged. as if it were an external repo using Symlinux. So from the perspective of the main tree, it would be as if you're importing this external package, even though you're still on the same Git tree. So this lets us make modifications to external repos and the consumers of those repos within the same PR, right? So this kind of avoids some headache we'd have if we just pulled everything out into external repos from the start. The second thing you can do is that anything that's staged gets automatically republished to those respective external repos. So this is so that anything that's not like Kubernetes core can still import these external repositories and use them for whatever purposes, right? So we follow this pattern for a lot of common libraries like ClientGo, API machinery, and whatnot. And so by doing this, we can build both the in-tree cloud providers by importing what we have in the staged directories, all without changing that single source of truth, right? So we're still developing in the staging directories, but then we can still build our cloud controller manager from the external repos, which are just cloned directly from what we have staged. And so the key here is being able to build both solutions, but maintaining that single source of truth, which is still the staging repo. And one of the challenges with trying to stage repositories, particularly like staging the cloud providers, is to break any potential circular dependencies we get by trying to extract this code as an external dependency. In other words, anything that's imported as an external dependency in case.io/Kubernetes can't depend back on case.io/Kubernetes. And there's a surprisingly long list of dependencies just within the cloud provider code that we need to tackle. This is sort of my call for contributions. If you're looking for ways to get involved and you love working with Go dependency management, because I know we all do, this is the issue to look at, issue 69585. That's where it's at. So once you break out those dependencies, we're able to then create those external cloud provider modules. And we're hoping that this isn't just a module for the cloud controller manager, but we want these modules to be a rich set of APIs and libraries that can then be consumed by other things in the ecosystem, like the cluster autoscaler or the cluster API or the virtual kubelet, right? So that was my long way of explaining why this effort is taking so long. So let's talk about some of the benefits we get by doing all this work, right? So imagine a future where we've been able to break apart all those dependencies and we move all the cloud provider code out of Kubernetes. What are we really gaining from doing this, right? The first and most immediate benefit will be smaller binaries, right? When we closely couple cloud providers into Kubernetes, we build this huge dependency tree, not just the cloud providers, but all the dependencies that the cloud providers depend on, right? And so, a couple people from Google, I think Walter and Daniel, they actually ran an experiment to see like how smaller do these binaries actually get if we remove all the cloud providers, right? So for the kubelet and the controller manager, we're cutting around 50% of the actual binary size. And for the kube API server, around 20%, right? So to me, that's a pretty good win. Imagine like all the Kubernetes binaries that get distributed in a day, and we're able to cut 30 to 40% of that bandwidth, especially for like on-prem or bare metal environments that don't need these libraries at all. Next benefit is separation of concern, right? We clutter a lot of the Kubernetes releases and the changelog with a lot of cloud provider specific things. And again, like for people who are running these massive like on-prem solutions, like they don't care about that, right? And in an ideal future, we want to be in a place where we keep the changelog to only contain what is relevant or what is considered the core of Kubernetes. And so like by doing this, we're able to actually do that. And if a cloud provider wants to talk about changes, we can just link out from the core changelog and redirect users to the changelog based on the providers. Next is that we want Kubernetes to truly run on an open cloud. I think that's a pretty big theme at KubeCon. At a time where multi and hybrid cloud solutions are becoming more common and more important, we really need to get this right early on, right? So this means that we have to continuously think about Kubernetes and try to make it as extendable and as pluggable as we can. And on this note, I would personally like to see more enterprises building like on-prem cloud providers based on their use cases. I think DigitalOcean is a great example where yes, we do provide a managed Kubernetes offering on our cloud, but we also run bare metal Kubernetes at a really large scale for a lot of our internal services. And we have really great internal APIs to manage that bare metal infrastructure. And we're seeing that it's more and more possible and beneficial for us to even build like an internal cloud provider so we can better integrate our bare metal Kubernetes with our bare metal infrastructure. Or to take it a step further, maybe you don't like the way a certain public cloud provider is implemented, and you want to change that, but you don't want to fork Kubernetes and maintain a fork of it. You just want to build that pluggable piece and change the behavior of a certain public cloud provider today. And so I'm optimistic by next year KubeCon, we're going to actually be able to provide the necessary functionalities to support those use cases. And lastly, this helps us move towards this idea of frameworks instead of interfaces, right? We're finding that interfaces are really good for things like CNI, CSI, and whatnot. But when we talk about like cloud provider integrations that span wider use cases, interfaces become very rigid, right? If you start to think about all the different expectations of cloud providers, such as like node states and conditions, right? Some providers will let you shut down a node, but some providers don't. If you think about like regions versus zones, right? Some providers have regions, some providers have zones, some providers have both, right? And we have a lot of like assumptions around what should be supported based on the interfaces that we have. Or we have these awkward things where we call it zones, but like if you're a cloud provider and you're implementing zones, you may just call it zones in the code, but it's actually regions, right? So we're trying to break a lot of those assumptions. Likewise for load balancers, you'll find providers have varying types of load balancers with application networking and whatnot. And in the end, you'll find that there's really no way to create a single API or a single interface that's going to satisfy every cloud provider out there, right? And so this idea of like having frameworks and libraries to build your own pluggable cloud controllers is going to be much better than like providing this rigid interface that we're forcing providers to implement. But ultimately, we can't actually like go down this path yet because we have to break a lot of those assumptions we have like, in the core of Kubernetes. And so like in this ideal future where we move everything out, we can start having meaningful conversations around like what this framework might look like. And so one thing that I've learned working in this effort is that the code and the architecture is only one side of the story. There's a huge community aspect of this effort that we really need to keep a strong focus on. When we talk about supporting existing and new cloud providers, we not only need to provide some repository where the code lives, but also a voice in the community and a governance model that allows those cloud providers to contribute back into our ecosystem. It was actually really interesting when I was at KubeCon Shanghai back in November, because like here we are in China, and there's huge interest for companies that want to run Kubernetes. But it was weird because like there was no SIG intro or SIG deep dive equivalent for like the actual cloud providers in China. And so a lot like our technical issues, there's a tough balancing act that we have to juggle. And so one of the things that we're struggling with is that just like we can't add every single cloud provider in the core of Kubernetes, like we can't just keep adding a SIG per cloud provider because that's not a sustainable model as well. And if we did this, we'd have more cloud provider SIGs than we do like other SIGs, right? So this doesn't scale, but it's also not acceptable for us to not provide some sort of structure where users of these cloud providers can still meet and discuss Kubernetes topics with respect to their cloud providers. So we're at a place where we're exploring what the new governing structure would look like, and we're leading towards this model where we want a single SIG representing the state of cloud providers, and we want cloud providers joining this one SIG as subprojects. And there are many motivating factors for us to do this. Preventing SIG sprawl is definitely a big one. But another one is to build solidarity, right? In today's model where cloud providers are like siloed into their own SIGs, it's hard for us to build things that has everyone's interest in mind. And so with the single SIG and the members of the SIG are representing the various cloud providers in the ecosystem, we can start to have these SIG meetings where we're addressing use cases that don't just apply to a single provider, but applies to all the providers. It's also important to note that we're also playing this balancing act of what we should even consider a cloud provider, right? It wouldn't be okay for me to set up a bunch of Raspberry Pi in my basement and call that an official Kubernetes cloud provider, right? So we're trying to set technical requirements and standards to make sure that cloud providers that have a strong interest in the community are also giving back and are being supported in the way that we need to support them. So if you want to learn more about some of the work we're doing and the state of all these efforts, I highly recommend coming to the SIG Cloud Provider intro that Chris and Jake are going to lead. So that's tomorrow at 1:45 p.m. And if you really want to contribute, or you really just want to dig deep into some of the technical challenges that we have in our SIG, I recommend coming to the deep dive, which is going to be on Thursday at 10:50 a.m. And with that, I want to say thank you for listening to my talk.